Hello everybody, coming back with another video today to help you out with Chapter 9, Lesson 3. We are doing transformations of quadratic functions. Your assignment today was on page 569, numbers 9 through 27 odd. Remember, those odd questions have the answers in the back of the book, so make sure you check your answers out when you complete these problems. And let's get started for today. So we're talking about transformations of quadratic functions. And we're always going to be referring to this quadratic function known as x squared, right? F of x equals x squared, and that is called the parent function. And we're going to look at this function and say, okay, what is happening with the graph? What different things do we notice? What different properties are happening, right? So f of x equals x squared is this parabolic shape, and its vertex is at 0, 0. And we're going to look at different transformations that are happening. And the first transformation we're going to look at is called a translation. A translation is whether or not this is being shifted or moved left or right or up or down. Okay, so that translation is moving that parabola in different ways. So if I want to move it up or down, right, that's changing the y-intercept essentially. So we can think about like slope-intercept form, and where that plus b at the end is my y-intercept. That's going to be very similar here when we're talking about quadratics, right? So for example, if I had f of x equals x squared plus 2, well, that's going to shift my quadratic or my parabola up 2 units. So now my vertex is going to be at 2, and now I have that parabolic shape. Notice it's still the same size, it's just now shifted up 2. Very similarly, if I have f of x equals x squared minus 2, well, then it's going to be shifted down 2, but it's still going to be pointing up. It's still going to have that same shape. It's just shifted down 2 units. Okay, so hopefully that kind of makes sense, where that y-intercept is just moving up or down. So that's if we're translating up or down. If we're talking about moving the shape left or right, we're going to have a little bit different change in our graph, or our equation, I should say. So if I have the function, say, g of x equals, and now I'm going to have this parenthesis here, it's going to be x minus, and now we have h squared, right? So now we have this whole quantity being squared. And if I have this, it's going to shift my parabola either left or right. And if this number here, this h, is greater than 0, so essentially, if this minus is still here, for example, if I have g of x equals x minus 2 squared, well, then it's going to shift right 2 units. Right? If this minus is still here, essentially, if h is positive, in this case h is 2, it's going to go right 2 units. Whereas if I have g of x equals x plus 2, well, now think about it, h has to be negative 2, so it's going to go left 2 units. Okay, so if I have this parenthesis and I'm adding a number, then it's going to move the parabola left. If I have this parenthesis and I'm subtracting a number, it's going to move the parabola to the right. Now we can throw in some other things here as well. If I stick a plus 2, or let's say plus 3 at the end, well, now it's being shifted 2 units to the right and also 3 units up. And the same thing, if I put a minus 3, that's being shifted 2 units to the left and 3 units down. Okay, so those are the translations. Those are the moving objects. Okay. Some other transformations we like to talk about are dilations and also reflections. If you have a reflection is shown through the coefficient on the x. So, for example, if I have 2x squared, my coefficient on the x is 2. Okay, since it's positive, it's going to be pointing upwards. If my coefficient on the x was negative, for example, let's say -2, then it's going to be pointing downwards. Okay, the bigger my number is, the narrower my parabola is going to be. Essentially, it's being stretched out vertically, right? So since I have a 2, it's starting to stretch out a little bit. Now, if this number was less than 1, but greater than 0, so we're talking about those fractions in there. So, for example, let's say we have f of x equals 1/2 x squared. That 1/2 compresses the parabola and makes it narrower. Okay, so it's being compressed vertically. So the larger my number, the more stretched out it's being. If it's small, if it's less than 1, it's being compressed, right? So notice that I didn't say negatives. I'm talking about just the number itself. So even if it's negative, it's still being stretched out. The negative just tells me it's facing downwards. So that is if it's being reflected, and then the dilation tells me those two numbers, whatever that coefficient is. Okay, so let's look at some practice here to kind of help you out. So for example, on, let's say, number 9, you have h of x equals -7 minus x squared, right? And if you want to rewrite this, you can. So you could absolutely rewrite this as -x squared minus 7. And now you have to ask yourself, okay, what does this tell me? Well, I noticed two things. One, this coefficient is negative, so that tells me it's being reflected over the y or the x-axis. And this -7 tells me my y-intercept is being shifted down 7. Okay, so that's how I would explain that transformation on number 9. Is essentially it's being flipped over the x-axis, or it's being reflected across the x-axis and shifted 7 units down. Okay, so reflected across the x-axis and shifted 7 units down. Or you could say translated 7 units down. Either one would work. Okay. Now, if you had something like number 10, where we're kind of throwing everything at you now. So on number 10, we have g of x equals 2, and then x minus 3 squared plus 8. Now, we got a lot going on, so we have to really take each part into consideration. Okay. This number out in front, right, this is going to go to the x, right? So this is essentially going to become 2x squared. So we know that my parabola is still going to be pointing upwards. It's going to be positive, right? And it's going to be stretched vertically because of that 2 on front, right? So it's going to be stretched vertically. We also know that this minus 3, since it's x minus 3, it's going to be shifted right by 3 units. And we also know that since this 8 is positive, it's going to be shifted up by 8 units. Okay? So 3 things are happening here. It's being shifted right 3 units, shifted up by 8 units, and it is being stretched vertically. Because we know that by that 2 outside of that x. Okay, so 3 different things happening there. So you have to look at each of those parts to figure out what is happening with this transformation. Okay. With 19, 21, and 23, you are trying to match the equation with the graph. Okay, I recommend looking at the equation first to figure out what the graph is. For example, if I wanted to say 18, I know it's being shifted down 4 units, and I know that it's pointing vertically, it's pointing up, and it's being compressed because of 1/3, right? And if I look, well, the only one that matches that is C, right? And if I wanted to do 19, I know it's being compressed because of the 1/3. I know it has to shift left 4 because that's a +4, so that means H is actually -4. And I know it's being moved downward 4, right? So left 4, down 4, and compressed. And if I look, the only one that it matches is A, right? So that's how you would define each of those parts to figure out which graph works best. Okay, and then 25 and 27, you are just figuring out which one is being stretched most vertically to least vertically. Okay. If you have any other questions, please feel free to email me, let me know, and I'll try to get back to you as soon as possible. Hope you're having a great day, and yeah, just keep up the good work. Thanks.